Okay, so we did the easy example, the bars are already alone. The medium example, we just had to get rid of one number to get the bars alone. Here we have a few numbers with the bars. So in the room, so -4 and -2. So I would say -2 is the best friend because they're more close like that. And then -4 is just like whatever. So best friends always go last. We'll get rid of him first. So we're going to add 4 to undo it. Add 4. We got bills and money. We're left with -10. Remember, when you're adding and subtracting, you're not using this. That's only for multiplication and division. So think of bills and money. And then right here we got -2, the absolute value of x plus 3. So when we look right here at this -2, a lot of people do this. Do not do that. -2 is being multiplied with the absolute value bars. I like to put that little dot to remind myself if I don't see -2 plus, -2 minus, -2 times, if I don't see it, it has to be times. The opposite of multiplication, to undo this, is division. So we divide by -2, we divide by -2. And this cancels. When we divide by a negative, remember we flip the sign. So instead of greater, we make it less. And then here, negative divided by a negative would be positive. Now we do use this for multiplication and division. Negative divided by a negative is a positive. Now we have the absolute value bars alone. Once the bars are alone, now we're ready to make our two cases. So we have our first case, x plus 3 is less than 5. Our second case is x plus 3 is greater than -5. Your positive case, you leave the symbol the same, less, stays less. Negative case, you flip the symbol. So instead of less, you make it greater. We solve each of these. 5 minus 3, 2. X is less than 2. Minus 3, bills and bills, -8. And x is greater than -8. We have to see if this is this and this, or this or this. So we go back to where the bars were alone. We go back here. We don't go back here. That's a less than symbol. So the symbol starts out like this. The symbol starts out like that, and we turn it towards the clock. So we turn it that way, towards the clock. And it looks like an A, so this one is actually an AND graph. So it's this inequality and this one. If you were to go back to the top at the original problem, it starts out as a greater than symbol. And when you turn it to the right, it's an OR graph. That's why you don't go to the original problem. You go to where the bars were alone. So on the graph, -8 comes first, open circle, and then 2 would be over here, open circle. So x can be anything less than 2. So 1 is less than 2, 0. Anything less than 2, and it has to be greater than -8. So 1 is greater than -8 and less than 2. -7 is greater than -8 and less than 2. So all the numbers in between here. If I want cheeseburger and fries, I want a cheeseburger and fries. I can't be one without the other. So it has to be less than 2 and greater than -8. So like 0, for example, is a solution because it's less than 2 and it's greater than -8. All these numbers right here are your solutions. So this is an example of an AND graph. So get the bars alone, make your two cases after the bars are alone. You don't make the two cases at the beginning. Once the bars are alone, then you make your two cases. Your positive case, leave the symbol. Your negative case, flip the symbol. Then you solve. You figure out if it's and or by going back here. And you rotate that symbol. So if it starts out a less than symbol, you rotate it, it looks like an A. So it's an AND graph. If it starts out a greater than symbol, you rotate it, it doesn't look like an A. So it has to be OR. And then you graph your solutions. So let's see, for example, 0. If we were to put 0 back into the equation, 0 plus 3 is 3. The distance from 3 to 0 is 3. And 3 is less than 5. It makes it true. If you were to put that into the original one, it would also be true. So these would be the solutions. Don't forget, when you're solving an absolute value equation. So this was the inequality, but if it was an equation, that you get the bars alone also, and you make your two cases. X plus 3 equals 6, and x plus 3 equals negative 6. And you solve both of these. Minus 3 minus 3, x equals 3. Minus 3 minus 3, x equals negative 9. So here, the difference between an equation and an inequality. Negative 9 still comes first, and negative 9 is a solution. X equals negative 9, so you can make a closed dot at negative 9. And 3 is here, and it is a solution. And these are your only two solutions on the whole number line. If it's an inequality, you have infinite solutions. All these numbers are solutions. All these numbers are solutions. Anything less than negative 9 or anything greater than 3. Here with an equation, it's just two solutions. All right, please make sense of it. Ask questions to each other and help each other out, but keep it real. Try them on your own. Okay, we don't have a lot of time left for the end of the semester. I think it's like 5 weeks left, or maybe 4. So time is ticking. Have a productive day. Be blessed.